Okay, this is my first attempt at standard 1.2. For the standard, I decided to do problem 1.13, which asks to consider a quantum system with an observable A that has three possible measurement results, A1, A2, and A3. For part A, we are just asked to write down the three kets A1, A2, and A3 corresponding to the possible results using matrix notation. So simply right here, it's really pretty trivial. You just write down each possible state in matrix notation. That we can see that right here. For part B, we're told that the system is prepared in the state 1 times the ket A1 minus 2 times the ket A2 plus 5 times the ket A3. We're told to write this state in matrix notation and calculate the probabilities of all possible measurement results of the observable A, and then to plot a histogram of the predicted measurement results. So here is how we write this in matrix notation. It's pretty simple. Just multiply the coefficient through to the matrices. Then to normalize, we follow this formula right here. We can see we work through, and then to solve for the constant, we simply take the square root of both sides, and we get the normalization constant 1 over square root of 30. So then we bring this out front, and this is our new state. Then to find the probability of each state, we simply dot the A1, A2, A3 matrices with this state. We notice when we dot that only the component we are dotting with matters, since the rest will just be 0. So to find the probability of each, we simply take the modulus squared of each component it corresponds to. So this should be 1 over 30, 4 over 30, and 25 over 30. I'm not sure why the square root is there. I must have made a mistake when I was typing it. But we essentially see that it's 1 over 30, and then negative 2 over square root of 30 squared, and then 5 over square root of 30 squared, which gives us these possibilities. I'm not sure why, but my histogram refuses to show up, but essentially what it looks like is a bar graph where A1 goes to 1 over 30, A2 goes to 4 over 30, and then the probability A3 is much larger, it goes to 25 over 30. And we note that these all add up to 1. Part C says that in a different experiment, the system is prepared in the state 2 times the ket A1 plus 3i times the ket A2, which essentially is plus 0 times the ket A3. We ask again to write this in matrix notation and calculate the probabilities. So simply, this is the matrix notation, just like as we did before. We normalize going through the same formula, and we get our normalization coefficient to be 1 over square root of 13. So we adjust our prepared state with the normalization. Then to find the probability, same reasoning before. When we're dotting with phi, we only need to worry about the state that we're dotting with, because the rest will go to 0. So probability A1 becomes 4 over 13, probability A2 becomes 9 over 13, and probability A3 becomes 0 over 13, because we're simply just we're squaring each of the moduluses. Again, for some reason the histogram won't show up, but essentially what it looks like is just a bar graph where A1 goes up to 4 over 13, A2 goes up to 9 over 13, and A3 will not have a bar at all because it has a probability of 0. And again, we note that the probabilities A1 and A2 add up to 13 over 13, which gives us 1.